Hello, I am Preeta Prasid, Assistant Professor, ISMR MCA Department. Welcome to the topic of different databases like Temporal Database, Spatial Database, Multimedia Database, and Personal Databases. So let's see what is Temporal Database. In a simple database, when we add time, it will become a temporal database. That is, it stores data related to time instances. It offers temporal data types and store information related to past, present, and future time. So temporal databases could be unitemporal, bitemporal, or tritemporal. For example, a patient database must store the information about the medical history of a patient. In broadcast sense, temporal databases encompass all database applications that require some aspect of time when organizing their information. So three types of time are there: valid time, transaction time, and bitemporal time. So let's see what is valid time. Valid time is a time period during which a fact is true in the real world. So we have to consider the start time and end time, so that the duration in this start time to end time, the value is this, something like that. And what are the uses? It will be for the computer application, medical systems, reservation systems, and financial applications. For example, computer applications, history of the file backup, right? So what is transaction time? So transaction time, it will be the time period during which the fact stored in the database was known. It means it will be storing the actual transaction time, at what time the data is entered into the database. So the use of this transaction time is for the rollback of the databases. And the third one, it is bitemporal data. So bitemporal data combines both valid and transaction time. It stores data with respect to both valid time and transaction time. So more preferably, it will be storing the three extra columns like the transaction time, valid start time, and valid end time. So time representation, the calendar organizes time into different time units for convenience, accommodates various calendars like Chinese calendar, Islamic, Hindu, Jewish, etc. So time representation, point events and duration events. Point events, single time point event, example bank deposit, that is, it will be storing at what time the amount is deposited and what time the account started and all. Duration event associated with specific time period. Time period is represented by start time and end time. So this is transaction time, bitemporal database, and valid time that we have already discussed. Incorporating time in relational database using tuple versioning. So every tuple we have to add the start time, that is valid start time, and valid end time. So see this example. In A, it is given valid time database. So apart from the normal columns, it is having VST and VET at the end. It is showing that is valid start time and valid end time. And for the B, it is transaction time database. So it is also storing transaction start time and transaction end time. And the third one, that is the combination of both, that is bitemporal database schema. So it is having four columns apart from the normal columns of the table, that is valid start time, valid end time, transaction start time, and transaction end time. So see this example of the employee and department table. So you can see that is the valid start time and valid end time is given over there for the employee table, and valid start time and valid end time is for the department table as well. So you can see there till that time and the start date, everything is mentioned over there. So using this, the history of the table can be fetched later. Temporal database concepts. Incorporating time in object-oriented databases using attribute versioning. A single complex object stores all temporal changes of the object. So two types, that is time varying attribute and non-time varying attribute. Time varying attribute, if we are considering the age, as per the time, the age of a person will be varying. Non-time varying attribute, that is whenever we are storing the date of birth of a person, it will not change as per the time. Now we can see the applications of temporal databases. There are many applications where the aspect of time is need to be maintained in the database. So some of the examples are healthcare, that is patient histories need to be maintained over there. In insurance, that is claims and accident histories are required. And for the finance, that is stock price details to be maintained. And for the personal management, that is salary and position history need to be maintained. Banking, that is the credit histories and debit histories is to be maintained. Now let's see spatial database. So what is spatial databases? A spatial database is a database system that is optimized to store and query basic spatial objects. So keep track of objects in multi-dimensional space. The examples are maps, GIS, that is Geographical Information System, weather and all. In general, spatial databases are n-dimensional. Now we are considering here two-dimensional. So spatial DBMS. So what is spatial DBMS? So spatial DBMS, which supports spatial indexing, efficient algorithms for processing spatial operations and domain specific rules for query optimization. So spatial data, it will be storing in different types of objects. So the objects will be in the form of point, line, polygon and all. The point, it means it can be a house, moving car, a city. And if we are considering the line, a polyline, it will be a river, cable, road and all. And for the polygon objects, it will be the forest, a lake, a city or a country. Spatial applications which uses spatial data are medical field, where the doctors use MRI reports to identify the disease. So now let's see spatial data and non-spatial data examples. The example for the non-spatial data includes name, phone numbers, address of the people and all. And for the spatial data, it will be the image representation like NASA satellite imagery and terabytes of data per day, weather and climate data, rivers, farms, ecological impact, medical imaging. So in these systems, the spatial data is mentioned. Like if we have to represent the weather forecasting, if the country map is given, so where the rain season is affected and all to be showed, so some spatial point to be mentioned here, stored for getting that information. Spatial and non-spatial queries. So from the spatial databases, we have to fetch the data using the queries. So non-spatial queries are, some of the example is given over there, that is the list the name of all bookstore with more than 10,000 titles. So this is one of the example for non-spatial queries. And for the spatial query, that is list all the customers who lives in Pune, which buildings are adjacent to the river. So these all are spatial queries. Typical spatial query is given over there. So already I explained, that is data types, point, line, string, polygon and all. And spatial operations are like overlap, distance and nearest neighbor. Callable from the query language, example SQL 3 of underlying DBMS. So when query is given for your reference, that is select s.name from senator S, where s.district area greater than 300. So some of the standards are given for the spatial queries like HTML W3 consortium standards. Here for the spatial queries, SQL 3 is a standard for query language. OGC is a standard for spatial data types and operators. Both standards widely support in industry spatial queries. GIS is a software to visualize and analyze spatial data using spatial analysis functions such as search, thematic search, search by region and all. So now let's move to the topic of multimedia databases. The multimedia database concept. The multimedia is a collection of related multimedia data. The MMDB stores data in the form of text, images, graphics, animation, audio and video. Multimedia database is a database that include one or more primary media file types, such as the text document, that is, it will be in the form of .txt, and the images, it will be in the form of jpg, and the audios, it will be in the form of .mp3. So what was the need of the multimedia databases? Nowadays, the type of data which is to be stored is varying. So here the type of multimedia data are available in current systems: text, graphics. So text will be, that is the unformatted or formatted text we can store, and for the graphics it can be the CGM format, PostScript format and all. Another, it is images and animations. So images can be in JPEG, MPEG format. The animations it will be the combination of the graphic data, images, it will be the sequence of the image or graphic data. And videos, the set of temporarily sequenced photographic data or presentation at specific rates, for example 30 frames per second. Structured audio and composite audio, it means that is the voices, sample data generated from oral recordings in a string of bits in digitized form. And composite or mixed multimedia data, it may be the combination of the voice and the video. So nature of multimedia applications. So multimedia data may be stored, delivered and utilized in many different ways. That is, we can store the multimedia images in a folder for the applications for retrieving, and the path we can store in the database. Otherwise, it can be stored in blob format as well. So next, coming into mobility and personal databases. So what will be this mobility and personal databases? So mobility and personal databases, we can consider it as mobiles and all. It means that is the database which can be movable. So it may be the personal database, right? The mobile computing environment consists of mobile computers, referred to as mobile host, and wired network of computers. The mobile host may be able to communicate with wired network through a wireless digital communication network. For example, wide area networks and wireless local area networks. Model for mobile communication. Mobile hosts communicate to the wired network via computers, referred to as mobile support stations. So each mobile support station manages those mobile hosts within its cell. When mobile hosts move between cells, there is a handoff control from one mobile support station to another. So direct communication without going through the mobile support station is also possible between the nearby mobile host. Database issues in mobile computing. So what may be the issues in mobile computing? So it may be for the query optimizations and identifying the location of the mobile database and the broadcast data. So there may be the issues. So network issues for the query optimization, that is connection time charges and number of bytes transmitted, battery power, and mobile users location may be parameter for the query, that is GIS queries for the kind of queries which is related to GIS, techniques to track location of large number of mobile hosts. Broadcast data can enable any number of clients to receive the same data at no extra cost. Users may need to be able to perform database updates even while the mobile computer is disconnected. So example is given here for your reference, that is mobile salesman records sales of products on local copy of the database can result in conflicts detected on reconnection, which may need to be resolved manually. It means that is he may be using his personal mobile for recording the sales data. So in local database it's getting updated, and while getting connected to the reconnection, so there may be conflict for calculating the sales. Routing and query processing. So for this, computing must consider the computing cost, that is user time, communication cost, energy. Communication cost may be connection time, that is used to assign monetary charges in some cellular systems, number of bytes or packets transferred used to compute charges in digital cellular systems. Time of day based charges vary based on peak or off peak periods. Energy optimize use of battery power by minimizing reception and transmission of data. Receiving radio signals require much less energy than transmitting radio signals. So next it is broadcast data. Mobile support stations can broadcast frequently requested data, allow mobile hosts to wait for needed data rather than having to consume energy transmitting a request. The broadcast data may be transmitted according to a fixed schedule or a changeable schedule. For changeable schedule, the broadcast schedule must itself be broadcast at a well-known radio frequency and at well-known time interval. Data reception may be interrupted by noises also. And the last, it is disconnectivity and consistency. Mobile host may remain in operation during periods of disconnection. Problems created if the user of the mobile host issues queries and updates on data that resides or is cached locally. So there are 2 points, recoverability and consistency. So for the consistency, cached data may become out of date, but the mobile host cannot discover until reconnection. And for the recoverability, updates entered on a disconnected machine may be lost if the mobile host fails. Since the mobile host represents a single point of failure, stable storage cannot be simulated well. So that's all. Thank you.